Right, question 5. You've got these position vectors. Remember, position vectors go from the origin. And what you can do is, if you wanted to, you could try and sketch some of these out. 1, 2, 3, 5, 7, 4, and then 4. So we're talking about somewhere along here, K. So that will be my A, B, C, and D is somewhere along here. So kind of that's how I wanted to see it. And then it says find the value of K for which D is a midpoint of AC. So the midpoint of AC, the midpoint there. Okay, let's see how we do that. What I can do is I can say, well, A is 1, 2, C is 7, 4. So the midpoint between these two is simply 1 plus 7 over 2 and 2 plus 4 over 2. And that gets me 8, so that's 4, 3. Midpoint 4, 3. And so therefore that's 4, which is handy because it wanted to be that. So K equals 3. So K equals 3. It's good to state those values there. So that's A. Now let's see how we answer B. Now these are separate questions. This is a separate one. So here's 2 values of K for which the magnitude of AD is root 13. So I need to find the magnitude of AD. I need to find the magnitude of AD. So it's Pythagoras theorem, isn't it? So I've got my A and my D. And so therefore, I'm going to say it's 4 minus 1 squared plus K minus 2 squared, all square rooted. And they're saying that the square root of this, so this equals 13. So that's what they're saying, is this equals 13. So that's going to be 9 plus K squared minus 4K plus 4 equals 13. That's really handy. So I've got here, that means that K squared minus 4K equals 0. So you can see how that works. And then if that's the case, I can then say K equals 4 or 0. So you can see here, if you factorize that, K equals 4 or 0. And I need to state that. And that's my values of K. Now, finally, tricky one. I guess all these are tricky if you can't do it. It says find one value for K for which the 4 points form a trapezium. Now, there's a variety of ways you can do this, and there are 3 possible different answers. So I want a trapezium. I want a trapezium. That could be lines that are parallel like that. So therefore I look for the gradient of A and BC here and see that it's compared to the gradient of that. I could have done, instead of that, I could have compared it maybe with saying the gradient of AB and then put D there and shown that that is then a trapezium. Or I could have gone for BD and AC, etc. But let's just do it this way. Let's look at the gradient of BC and compare that to the gradient of AD. So BC, I'm going to go that way there. So B is 3, 5, and C is 7, 4. So the gradient here, difference in Y, so let's do 7 minus 3 over, oops, daisy, Y Simon. So I'm looking at the Y values. So I'm going to do 4, what am I going to do? 5 minus 4, let's do it this way, over 3 minus 7. And that's going to equal, so that's my BC or my C to B. So I now need my A and D, 1, 2, 4, and K. So here I'm going to do K minus 2 over 4 minus 1. As I said, there are 2 other ways to do this. but this is 1. So it's 1 over negative 4. So it's minus a quarter equals k minus 2 over negative 3 times everything by negative 3. You get 3/4 add 2. So therefore k equals, if you did this, 5 over 4. But again, use your calculator to help you with that. Okay, that's positive 3. So that makes that minus 3/4, yes, 5 over 4. As I said, there are two other ways of doing this one.